Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 6, 2026, about 4 days ago. It demonstrates the first instance of a large language model passing the Japanese bar examination without simplifying the question structure, achieving a score of 96, which comfortably clears the passing threshold of 93. The paper is titled, "Self-Verification is All You Need to Pass the Japanese Bar Examination." And as we'll see later, the results suggest that simpler, single-model strategies can actually outperform complex multi-agent systems in high-stakes professional reasoning. Table 1 breaks down the critical difference in training data strategy. The top section illustrates the standard JBEQA dataset, which decomposes complex exam problems into independent true or false snippets to create a large pool of examples. In contrast, the bottom section shows the author's new dataset. This version preserves the original, composite structure where multiple statements must be evaluated jointly. Even though this results in a much smaller dataset of only 460 questions, retaining this structural complexity turns out to be essential. Figure 1 illustrates the inference method used on these complex questions. Starting on the left, the model takes the original exam format and generates an initial answer, like 1, 1, 2. Then it enters a self-verification stage where it critiques its own logic. Notice how it identifies that the second answer is incorrect and suggests a modification. This leads to the corrected final answer on the right. Importantly, the dashed lines at the bottom show that this entire process uses shared model parameters, meaning one single model acts as both the solver and the verifier. Table 2 lists the specific prompts that guide this process. The first row establishes the basic persona of a test taker. The large middle section defines the answer format, which is incredibly strict. It explicitly commands the model to output only the answer number and forbids any explanatory text or intermediate symbols. Finally, the bottom row contains the verification instruction, which shifts the persona to a reviewer who checks for clear errors before finalizing the submission. Now, Table 3 presents the final results on the RIWA 6 exam. The official passing score, shown in the second row, is 93. While base models and those trained on decomposed data fail to reach this, look at the rows for the author's format-faithful fine-tuning. When combined with self-verification, this approach achieves an average score of nearly 95, effectively clearing the bar. Interestingly, the multi-agent systems at the bottom significantly underperform, scoring only in the 70s, which confirms that added complexity does not always yield better reasoning. To see what this looks like in practice, Table 4 provides specific examples comparing the model outputs against the ground truth. In question 1, up top, the task requires judging 3 legal statements to produce a code like 211. The results row beneath it shows that while the baseline and decomposed models struggle, the author's method hits the correct sequence perfectly. Then, look at question 3 at the bottom to see verification in action. The standard model, labeled hours, misses a digit and only gets partial credit. But the column for hours plus verses shows the verified version fixing that specific error to earn full points. Table 5 details the prompts for the multi-agent baseline, which, as we saw, underperformed. The pipeline divides the task into 4 distinct roles. First, the retriever identifies relevant past questions that share the same legal domain. Next, the verifier and extractor filter these results to distill generalizable legal rules. Finally, the reasoner applies this knowledge to answer the specific question. The authors suggest this fragmentation hurts performance, because errors propagate between steps without a shared model state to catch them. Wrapping up, 2 key takeaways stand out. First, alignment creates better results than complexity. The study proves that a single model trained on format-faithful data outperforms intricate multi-agent systems that rely on simplified questions. Second, a simple self-verification step effectively boosts reliability in high-stakes professional reasoning. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.